Hi, this is our second video from F1, and it covers problems 11 through 28. So I'm just kind of giving you some examples, and my next video will continue from after 28. Actually 29 through 44 will be our next one, and I'll give you a fourth video, our final video from this section, from a couple of application problems. And but on this one right here, they just want you to, on the number 11, they want you to name which quadrant you're in, and that's all. They're not asking you to plot it, they just want to know which quadrant it's in. So, and the next one, we're going to find the distance between these 2 points, and we'll be using the distance formula that I gave you in the overview section, and I'll put it on here to remind you what that is when we get to this problem. And the same thing that happens on 27, but if you notice, this point is not known. It's AB. And but let's start with number 11, and they just want to know which quadrant or axis it lies on. So -3, 2, notice the abscissa is negative and the ordinate is positive. So remember, the abscissa is the horizontal axis and the ordinate is the y-axis. So -3 means you go left, and then 2 is up. So if you remember, this is the first quadrant, this is the second quadrant, third quadrant, and fourth quadrant. So -3, 2 went left, and then 2 went up. So you're in this quadrant. So the second quadrant is the answer. B, 6, 0. Now 6 is the abscissa, so it's the x-coordinate, and 6 is to the right, so it's positive. 0 means you don't go up and you don't go down. It just stays on the axis. So it says the quadrant or axis the point lies on, so it is the x-axis or the horizontal axis. You can call either one. Let's just call it the x-axis. Now -2, -2, now the abscissa and the ordinate are both negative. The x-coordinate and the y-coordinate are both negative. So -2 means you go left, -2 again means you go down. So you're in this quadrant down here in the third quadrant. 6, 5, the abscissa and the ordinate, the x-coordinate and the y-coordinate are both positive, so you go right and then up. So you're in the first quadrant. Now 0, -3, 0 means the abscissa doesn't mean you don't go right or left, you stay put. But -3, which is the ordinate, which is the y-coordinate, means you go down. So you're not in a quadrant, so it's one of those quadrantal points. So you're on the y-axis, you're on the vertical axis. So it's the y-axis. And then 6, -3, 6 is positive, so you go to the right. The abscissa is right, or left, but this is 6 is positive, so it's right. And then -3, you're down in this quadrant here, so that's the fourth quadrant. So that one was, fairly simple. Just had to remember which quadrants you're in. Now in 23, it says find the distance between these 2 points, P1 and P2. So if you remember the distance formula, a lot of people, when it comes to studying for tests, they think, oh, this one's pretty easy. So they don't study it. And let's see, if it's easy, why should I study so much for it? It's because the formula itself. They don't remember the formula verbatim. What I mean by that is they'll leave the squares off, and I don't care what your points are, you're not going to get the answer right because your squares are missing. Or they'll put the squares there, but they won't put a plus between them. They'll put a minus between those. That's what I'm saying. The formulas have to be solid. If you don't have the formulas, you don't have the answer. So you have to have the formulas the way they should be. So that's a given. And but I've taught for many years, and I've seen students, I just didn't remember the formula, so I didn't study them because I thought it was going to be easy. And it's because it's that one little thing that they forget to square, they forget to put a plus where there's a minus, or put a minus where there's supposed to be a plus. But if they had the formula down, that would have been an easy 6 points or 5 points where the problem's worth. And otherwise, now they got a 0 out of 6, which can bring down the grade pretty quickly. So you got to know the formulas. And so now it's just a matter of just placing the numbers in the appropriate place. So subtract the x coordinates. So it's going to be, now you're like, well, which one do you use? Do you go 4 minus a negative 2, or do you go do a negative 2 minus 4? Really, it doesn't matter, because you're going to square it anyway. So for example, if you had like 5 minus 3. 5 minus 3 is 2. But you got to square it, because that's what they got to be. So 5 minus 3 is 2, and when you square it, it becomes 4. But let's say you did it the other way around. Let's say I did 3 minus 5. Now, which one is it? Well, let's see what happens. What's 3 minus 5? Well, that's negative 2. But what happens when you square negative 2? Oh, that's 4 too. So it doesn't matter which way you go with it. You can go 4 take away negative 2, and that's going to be a 6, by the way. And then 6 squared is 36. But if you go negative 2 minus 4, well, that's negative 6. And negative 6 squared is also 36. So it doesn't really matter which way you go with it. And so it's going to be 4 take away negative 2 squared plus, remember it's plus, and then negative 2 take away negative 5 squared. So the hardest thing, I guess, would be now, if you know that you know the formula, is being able to subtract negatives and or subtracting the bigger number from a smaller number. Calculators can handle those no problem nowadays, so there's really no excuse to miss this, because you can just punch that in, 4 take away negative 2, and you can get it. So, but a lot of people will try to do it in their head, and that you should be able to, but you got the calculator as you're checking to make sure you're doing your mental math correctly. So 4 take away negative 2 is 6, and 6 squared again is 36. Plus, and then negative 2 take away negative 5, that is a negative, all it was a dot. So negative 2 plus 5, 2 negatives make a positive, so negative 2 plus 5 is 3, and then 3 squared is 9. So that's going to be the square root of 45. Now before I go any further, I'm just going to let you know the distance between these 2 points on the Cartesian plane. Now 4 negative 2 is going to be in the 4th quadrant. Point 4, then down 2. And negative 2 and negative 5 is in the 3rd quadrant. So they're kind of both down in these bottom 2 quadrants down here. Then you're going to find the distance between those 2 points. Well, the distance between those 2 points is just under 7. How do you know that? Well, square root of 49 is 7. And square root of 45 is more than the square root of 36, which is 6. So it's between 6 and 7. Now you're like, well, what do I do? Well, it depends on what they ask. Sometimes they ask you to round it to the nearest decimal, so then you take the square root of 45 in your calculator, and then be 6 point blah blah blah, and then you get that answer. Sometimes they just want you to simplify it, and so the square root of 45 has a perfect square in it. It's going to be 9 times 5, and most of the times that's the way they like it. I'm not a big fan of this, but this is the way the books nowadays are doing this. And the square root of 9 is 3, so this is 3 square root of 5. To me, if I want to find the distance between 2 locations or 2 stakes, and it's going to be, to me, it makes more sense 6 point something another than it does 3 times the square root of 5. I mean, logically in my head, I'm thinking, okay, 3 square root of 5, I can figure out what that is, but 6 point something makes more mental. To me, it makes more sense to me doing it as a decimal, but most of the time they're going to want it this way. So it's going to be 3 square root of 5, and I think that's just formal math. And I'm not so formal in my learning math. I do it very informally, and that's how I do it. So I learned it. So but anyway, so it's 3 square root of 5. Now the next one, same formula. It's just basically the difference of the x's plus the difference of the y's. Now I want you to notice what I just did. I did x1 minus x2 squared as opposed to x2 minus x1 squared. But because remember what I said, it doesn't matter the way you do the ordered pairs. So the subscripts doesn't matter the order that you go with them. Okay? So subtract the x coordinates. So A is this x coordinate minus the other x coordinate, which over here is this number, 0 squared, plus Now the difference of the y coordinates, the difference of the ordinates, b take away 0 squared. So it's the square root of a squared plus b squared. Now, some people get, they try to do too much because they think you can. And just because it looks like you probably can doesn't mean you should do it. Square root of a squared plus b squared is not a plus b. Yeah, sure it is. Square root of a squared is a, square root of b squared is b, but there's a plus between them. What you're confusing, if you think that's true, is the square root of a squared times b squared. Then that would be a times b. But there's a plus between them. And you can't break up square roots. And this is the best way to break that cycle for you is punch numbers in to show what I mean by this. This is going to be 16 plus 9. The square root of 16 plus 9. If you think this is a plus b, then you should agree with this. Square root of 4 squared plus 3 squared. Because 4 squared is 16 and 3 squared is 9. Well, if you think the square root of a squared plus b squared, if you think this is a plus b, then you should agree that this is equals to 4 plus 3. And that 4 plus 3 is 7. Is the answer 7? Well, what's 16 plus 9? Well, we know that's 25. And the square root of 25, it's not 7, it's 5. So 5 equals the square root of 25, and 25 is 16 plus 9. And yeah, well, where's the mistake made? It looks everything is good. The mistake is right there. That's not true. And this is the best way to break that cycle for people. Is if you think something can be simplified, put numbers in there and see what happens. And if the numbers work, then you might be onto something. But if they don't work, 5 does not equal 7, then what you're thinking is not valid. So you're going from the abstract to the concrete. So if you're trying to figure out if something abstract is true or not, make it concrete. Use numbers that you're aware of and see if it works or not. If it doesn't work for the numbers, then the abstract doesn't work either. So, but anyway, this is the second video of F1, and it covers problems 11 through 28. So, thank you for watching.